Welcome to Ancient Edge, where we unearth the forgotten knowledge that shaped civilizations. Today we're embarking on a journey across cold northern seas, into the workshops of the world's most legendary shipbuilders. Imagine vessels that sailed for centuries, battling tempests that would shatter modern crafts, yet their wooden hulls remained unyielding against the relentless assault of salt water. While our contemporary ships corrode and decay within decades despite advanced materials and chemical treatments, the Vikings constructed vessels that defied both time and ocean. How did these Norse craftsmen achieve what seems impossible by today's standards? The answer lies not in mysticism, but in a sophisticated understanding of natural chemistry that we're only beginning to appreciate. We're about to uncover the alchemical secrets that gave Viking longships their legendary marine durability. The archaeological record presents us with an astonishing paradox. When researchers excavate Viking burial ships like the Oseberg or Gokstad vessels, discovered in Norwegian clay after over 1,000 years, they find wood that remains remarkably intact, its structure preserved with astounding fidelity. These ships didn't merely survive in protected museum conditions, they endured decades of active service in the brutal North Atlantic, subjected to constant saltwater immersion, temperature extremes, and biological attack from marine organisms. Modern maritime engineers struggle to extend the lifespan of treated lumber beyond 20 or 30 years in similar conditions. Steel vessels fare little better, succumbing to corrosion despite expensive coatings and cathodic protection systems. Yet, Viking ships sailed generation after generation, their wooden frames resisting the very forces that make saltwater one of nature's most destructive environments. This wasn't luck or supernatural intervention. The Vikings possessed empirical knowledge of wood preservation that represented centuries of accumulated wisdom, a chemical understanding encoded in technique rather than textbook, passed from master shipwright to apprentice through demonstration and practice. The secret of Viking ship longevity began long before the first plank touched water, deep in the forests of Scandinavia, where shipwrights selected their materials with discriminating precision. Oak dominated their construction for critical structural elements, chosen not arbitrarily, but for its dense cellular structure and natural resistance to decay. The Vikings understood that oak heartwood contains tannins and other phenolic compounds that naturally inhibit fungal growth and bacterial decomposition, but species selection was only the beginning. They felled trees during winter dormancy when sap flow ceased, ensuring minimal moisture content that would later facilitate treatment absorption. Rather than sawing planks, which severs wood fibers and creates vulnerable edges, Viking craftsmen split logs along the grain using axes and wedges, producing planks where every fiber remained intact from surface to core. This technique, called radial splitting, created boards with inherent strength and water resistance that sawn lumber could never match. The timber was then seasoned for years, sometimes submerged in freshwater bogs where low oxygen environments prevented rot, while tannins leached from the surrounding peat into the wood, creating a preliminary preservation treatment before human intervention even began. The true genius of Viking preservation lay in their mastery of natural chemical treatments, formulations that modern science is only now beginning to fully understand. At the heart of their methodology was pine tar, a substance produced through the controlled pyrolysis of pine wood or stumps in earthen kilns. This destructive distillation process yielded a thick, aromatic liquid rich in complex organic compounds including phenols, guaiacols, and creosote derivatives that possess powerful antimicrobial and water-repelling properties. Chemical analysis of residues recovered from Viking archaeological sites reveals a sophisticated compound, not pure pine tar, but carefully balanced mixtures incorporating animal fats such as tallow and beeswax. This wasn't random mixing, but deliberate chemistry. The addition of fats lowered the tar's melting point and maintained flexibility in frigid northern waters, preventing the brittle cracking that would compromise waterproofing. Beeswax contributed additional hydrophobic properties while creating a sacrificial barrier that abraded away slowly, rather than exposing underlying wood to sudden deterioration. Some evidence suggests the incorporation of fish oils which would have contributed omega-3 fatty acids known to cross-link and polymerize into durable protective films. The Vikings were essentially creating biopolymer coatings centuries before organic chemistry existed as a discipline. The application of these treatments was as crucial as their formulation, integrated seamlessly into the construction process itself. Viking shipwrights employed the clinker-built technique, where planks overlapped like scales on a fish, creating a hull that could flex with wave action rather than fighting against it. Before fastening these strakes with iron rivets, craftsmen packed the overlapping seams with wool or animal hair that had been thoroughly saturated in hot tar mixtures. This caulking wasn't merely stuffed into gaps, it was compressed under controlled tension, as the planks were drawn together, creating gaskets that would swell slightly when wet, ensuring watertight integrity even as the wood expanded and contracted through seasonal cycles. The entire exterior hull received multiple applications of the tar compound, applied hot, so it would penetrate deeply into the wood's cellular structure rather than merely coating the surface. Archaeological evidence from well-preserved wrecks shows this treatment penetrated several millimeters into oak planks, creating a protective zone where the tar's antimicrobial compounds prevented the establishment of wood-boring organisms and decay fungi. The process was repeated periodically throughout a ship's service life, creating accumulating layers that formed an increasingly impenetrable barrier. This maintenance regime represented an early understanding of sacrificial protection, allowing outer layers to weather away while preserving the structural core. Contemporary materials science is, well, rediscovering what Viking shipwrights knew intuitively. Modern wood preservatives rely heavily on toxic compounds like copper arsenate or chromium treatments that pose environmental hazards and still fail to match the longevity of Viking methods. Recent research programs have attempted to replicate Viking tar formulations, finding that the complex mixture of compounds in traditional preparations outperforms single-ingredient modern alternatives. The combination of penetrating preservation with flexible surface protection creates a synergistic effect that neither approach achieves alone. Moreover, the Viking emphasis on working with wood's natural properties rather than against them, selecting appropriate species, respecting grain orientation, allowing flexibility rather than demanding rigidity, represents design philosophy that transcends mere chemistry. Their ships succeeded because every element from forest to ocean was considered as part of an integrated system, where material selection, structural design, chemical treatment, and maintenance practices all reinforced one another. This holistic approach challenges our modern tendency toward material specialization and throws into relief the surprising sophistication of pre-industrial technology. The Vikings didn't have laboratories or electron microscopes, yet they developed preservation technology that modern science struggles to surpass. Their legacy reminds us that innovation isn't always about discovering something new. Sometimes it's about rediscovering wisdom we've forgotten in our rush towards synthetic solutions. If this journey into ancient maritime chemistry has sparked your curiosity, subscribe to Ancient Edge, where we continue excavating the ingenious solutions our ancestors developed to thrive in an unforgiving world. Share this video with anyone fascinated by the intersection of history and science, and join us next time as we uncover more secrets that prove the past was far more sophisticated than we ever imagined. The knowledge is waiting. We just need to look.